Hi everyone. Today I'll be demonstrating my health monitoring application, which measures the heart rate, respiratory rate, and monitors symptoms through a clean and user-friendly interface. The application also stores all collected data in an SQLite database for further analysis. Uh, so my app is called Context Monitoring App 2 because I messed up on the first one and I had to make a new one, so don't mind that. Let's start by launching the application on Android Studio emulator. Uh, okay, yeah. So this is my app. This is the layout, folks up. uh, First, let's measure the heart rate. I'll click on the measure heart rate button. We can see on the log cat uh, that, yeah, it's currently measuring the heart rate. The app processes the video file stored on the device to calculate the heart rate. This takes a few moments as it analyzes the frames from the video to determine the heart rate. Okay, so as you can see, the heart rate has been calculated and displayed on the screen. Now, let's measure the respiratory rate. Yeah, this takes a lot less time. The app reads data from the three CSV files representing the X, Y, and Z axes to calculate the respiratory rate. As you can see, the respiratory rate has been calculated and is now displayed on the screen. Next, let's navigate to the symptom logging page by clicking the symptoms button. Here we can log various symptoms along with their severity. Each symptom has a checkbox and a rating bar. You can rate the severity of each symptom on a scale of 1 to 5. The checkbox is automatically checked when you give it a rating. After rating let's just give some ratings randomly to some of these symptoms, and then I'll click on the upload symptoms button. As you can see, a toast message confirms that the data has been saved successfully. Now I'll move on to the app inspection and database inspector. Here you can see some of the IDs. So yeah, I've measured the heart rate and the symptoms 4 times with 4 different IDs. And you can see uh, the heart rate, respiratory rate, and the latest one that I did in this video, nausea 3, headache 2, sore throat 4, which is which seems good, I think. So yeah, now let's dive into the code explanation. I'll stop the emulator, minimize all this stuff. Yeah. So yeah, let's now dive into the code, starting with the heart rate collection. The heart rate is calculated using the heart rate calculator function in the heart rate calculator.kt. This is my main activity. There is, yeah, this is the measure heart rate function. Now, this calls the heart rate calculator. We'll move on to the heart rate calculator.kotlin. Now, here, the function uses media metadata retriever to extract frames from a video file. Specifically, it sets the video file as a data source and extracts frames at regular intervals using the get frame at index method. The core logic for heart rate calculation is based on analyzing the color values in a specific region of each frame. It calculates the average color intensity in a specific area of the frames to detect changes over time, which correspond to the heartbeat. The changes in intensity are counted, and this count is used to determine the heart rate by estimating the number of beats per minute. The result is then displayed on the screen. The method involves a series of image processing techniques to analyze the frames and extract the heart rate from subtle changes in the video's pixel values. Now let's move on to the heart rate, respiratory rate collection. I'll go to the main activity. Yep. This is the function to calculate respiratory rate, and this utilizes the respiratory rate calculator in the other file. The respiratory rate is calculated by analyzing accelerometer data, the read CSV from assets function in the csvutils.kt reads the data from the three CSV files, which represent the X, Y, and Z axes of the accelerometer readings. This function reads each line from the CSV files, converts it into a list of float values, and then returns this list for processing. The respiratory rate calculator function then takes these lists of the values and analyzes them to detect the breathing pattern. It counts the number of breaths over a period to determine the respiratory rate. The calculated respiratory rate is then displayed on the UI, providing a quantitative measure of the user's breathing. Now we move on to the symptom monitoring, which is implemented in the symptom logging activity.kotlin. Now, this activity uses a recycler view to display a list of symptoms, with each symptom consisting of a checkbox and a rating bar. The symptoms are displayed using a custom adapter called the symptom uh, adapter. Yeah. In the adapter, we handle the interaction between the UI components and the data. When a rating is given to a symptom, the checkbox is automatically checked to indicate that the symptom is selected. This behavior is implemented in the on ratings bar change listener. Uh, now, a method on the on bind view holder. If the user reads a symptom, the adapter sets the checkbox to checked to indicate selection. This interaction provides a seamless user experience, my bad, making it easy to select and read symptoms quickly. Now, let's move on to the database creation. We are using SQLite to store the collected health data. The database helper class, SQL data, health data SQLite helper manages the creation and maintenance of the database. This class extends the SQLite open helper and overrides the onCreate and onUpgrade methods. The onCreate method defines the SQL query to create database table named health data, which contains columns for heart rate, respiratory rate, and each symptom's rating. The insert health data. Okay. The insert health data method accepts the health data object and inserts it into the database using the content values. This method is called when the user clicks the upload symptoms button in the symptom logging activity. Now, to retrieve the stored data, the get all health data method uh, queries the database and returns a list of health data objects. This function is useful for debugging and can be used for exporting the data. By using SQLite, we ensure that the collected health data is stored locally on the device for future reference or analysis. And by the way, by storing locally, I remember one thing that I uploaded my MP4 video for the heart rate um, in the device explorer uh, storage emulated 0 download, and this is the MP4 video, and which we're parsing in the heart rate calculator function. Now, in summary, this application demonstrates how to measure and log health data such as heart rate, respiratory rate, and symptoms using Android's UI components and an SQLite database. We've covered the entire flow of collecting, displaying, and storing this data in a structured manner. Now, thank you for watching. And if you have any questions, feel free to reach out. Thank you.